Hi everyone, Dave here. In this third episode of the Off-Grid Solar Workshop upgrade project, I'm installing cable management, a breaker box, a precision digital voltmeter, and a Coulomb counting battery meter. All related videos will be linked down below in the description. Outside I have 1200 watts of solar panels, and those are going to be feeding the charge controller and keeping the air conditioner running and the batteries charged. The charge controller needs a PV DC rated breaker to turn the solar panels on and off as needed. I don't have a name brand breaker at this time. I'm looking for an American brand, but I haven't found one yet that I like, so I'm going to stick with this breaker. It's a 10 amp DC rated breaker. Cable raceways, also known generically as cable management, can be a great way to clean up the appearance of a DIY solar power installation. If you're doing an installation that requires compliance with a electrical code, you should be careful not to mix high voltage DC conductors with other conductors, as that might not be permitted. This DIY solar power installation is a work in progress, and I intend to further refine it later, but you will be able to see in this video how just a few pieces of cable raceway can make all the difference in the world. Right now I'm mounting some cable management. And these will protect and obscure the cables so they look neater and they don't get tangled up. I'm using 1/2 inch panhead sheet metal screws and a nylon washer. There we go. I'm not going to show all of this work, just some of it so you get the idea. You can see that I'm mounting them in a certain pattern. There's going to be more of them, and it depends on where I need to run the wires. This should get me started though. I can go ahead and run my solar panel cables in here, and they'll come in here, make a turn, and go down to the charge controller area, as well as there's going to be some electronics mounted here. I'll get to that in a minute. This is a piece of recycled screen track. I cut out some openings in it and drilled some holes, and this will be used to hold the voltmeter. This is a precision digital voltmeter, and I've become very fond of using these with my lithium iron phosphate battery banks. They give you an extra digit of precision on the right hand side, and they don't use a lot of power. And really, this has just been my preferred way of monitoring my battery banks. I've been doing it for years, and for some reason I just can't get away from it. There's also going to be one of these things. This is a Coulomb counting amp meter. These work pretty well, and in my experience they're quite helpful in determining how much power you have. At the very least, you can be pretty sure how much power is in the battery. Of course, it's not exact. It's kind of like a gas gauge or a fuel gauge for your battery bank. So that will go in here. There we go. And the voltmeter, make sure I've got it the right way up, will go in here. At least I hope it will. There we go. Okay. There we go. That's what it's going to look like. I'll probably add one or two other things here later, but this will get me by for now. On the back, of course, there's going to be cables, but those will be hidden. Those will not be visible from the front. Let's go ahead and mount this on the board and see what it looks like. Let's get some screws. Alright, I believe these are M2 screws. I'm not sure, but I happen to have these, whatever they are. Let's go ahead and mount this on the board here. I did not record all the installation of the standoffs, all the measuring and marking that I did. I just don't think people want to see that. There's enough of that on my channel already in older videos. Alright, we have... yeah, it's pretty solid. I don't think this thing is coming off. There we go. Yeah, it's on there. It's not going anywhere. I do need to run the cabling, but I'm gonna wait until later to do that. And once I run the cables, of course, they'll all be hidden. There we go. Try to get these as lined up as I can, but it's very tedious. There's the power board so far. It's coming along. I believe I will have to mount some more of these cable management raceways as soon as possible, because I'm going to have some cables coming probably this way and probably down here as well. But this will get me started, and some of the stuff you just have to sit back and look at it and think about it for a while. What I hate doing is drilling a lot of holes in the board and then you find out you don't want to mount something there, so I'm always hesitant to drill a hole until I've thought about it. You can't take those away, they're permanent. And I like things to look clean and neat for the most part, so I'm not going to drill a bunch of holes and make a bunch of mistakes if I can avoid it. But I'm pretty sure I'll be mounting another raceway right here. But I'm going to wait until I have all the wires measured out and see exactly where those wires end up before I do that. In any case, this is enough to get my circuit breaker up and running, my precision voltmeter, and my Coulomb counting amp meter. Alright, let's move on to the next step. On the back of the circuit breaker box, there's these various shapes and patterns, and these are called knockouts. You're supposed to be able to take a screwdriver or something and just knock those out. Sometimes they do, sometimes they don't. I'll certainly give it a try. That one came out pretty easily. They don't always. For right now, I'm just going to mount the circuit breaker box. So I punched out the mounting holes so I can go ahead and do that. And I'm not exactly sure where the wires are going to go in or out. There are knockouts all around. This box is going to fit right here on the board. I'm not exactly sure where the wires are going to come in or out, so I haven't hit those knockouts yet. I'm not worried about it right now. I'm just going to get this mounted and get my breaker in there and start working on running the solar panel cables over here where I can connect them. Alright, there's the circuit breaker box. Starting to mount that. Here is a Langier circuit breaker. I'm kind of fond of these because they're affordable and they seem to be built well enough. They do list some specs on their store page, so I use these breakers because they're cheaper. Let's go ahead and put that in. This is just going to be a 10 amp breaker. It's going to take positive and negative, and this is a double pole breaker, so the positive and negative are going to come in here. This is a DC breaker, 500 volts, double pole, and then the positive and negative will come in here, and the positive and negative will exit out at the bottom. And then those wires will go over to my charge controller, and eventually I'll probably double the breakers in here, but this will do for now. It'll do the job. There's what it looks like so far. I think now I'm going to get some cabling and wires and start running the wires where I need them to be, and start getting a feel for how long they need to be and where exactly I'm going to route them after they enter at this point here, because I'm not going to do any cable management on this end right here. On this side, I'm just going to leave it alone for now and focus entirely on this side of the board. The PV cables are going to come from right here and enter in right here. Later on, I may do some cable management on this other board, but this is used for research and development, and I kind of just want to leave it alone for now. Whereas this board here is going to be a permanent install, and it needs to be neat and tidy. Helps keep my blood pressure down. I don't want to see too many wires hanging around. There's enough wires in this shop already, as if you haven't noticed. Let's check on the inverter here. Right now I'm running a few different loads, small loads. It's been very cool lately, but I'm just keeping the batteries topped off. Charge controller is kind of just idling along here. 100 watts, 120 watts. And I'm not running my air conditioner on this inverter. The reason for that is I'll show you. This is the reason. Right now I have the XE and Y batteries, and those are powering another inverter. Yes, I have two of them. That's how much I love these inverters. I got another one. I could not help myself. Ran up the credit card and got me another one of these 1200 watt inverters. This is for a review that I'm doing, and I'm just letting it run my air conditioner, and we'll see what happens. Looks like it's about halfway through the test right now, so Just waiting for the results to make sure these batteries actually perform the way they're supposed to. Well, there's the current status of the solar power equipment board for the off-grid solar workshop. It's coming along. This has been recorded over a period of many days. This is not something I just go out in my workshop and do. It's just being worked on as time permits, as I have the opportunity, as health permits. You can see that there's a breaker box securely mounted. The cables are coming out. All the wires are beginning to fall into the cable management, which is running along the top. And of course I'm going to keep adding to that, but that's enough to get me started. It's beginning to make the wires look a lot better. Got the inverter running, and my digital voltmeter is up. And if you're interested in learning why I use a precision digital voltmeter with an additional digit over on the right hand side, there's a link in the description to a video where I explain all the logic and reasoning behind it. It's the same type of voltmeter I have over here, which is of course powered off because this system is not currently active right now. It's a standby system for emergency purposes. And it's a good bench power supply if I need it. I use that to test my ovens and so forth. Next task is get this Coulomb counting amp meter up and running. You cannot see it, but the wiring is already there. The wiring goes over here and in the cable management. I do have an additional charge controller planned for this area here, but of course it's not installed yet. It's not too urgent really because this one here is managing just fine. It's doing the job. Okay, let's get the shunt installed. I have to make some modifications to that before it will fit. Here is the shunt for the Coulomb counting amp meter. I've already put a wire on there. I had some purple high strand count silicone wire and I only need one wire. Really don't have much use usually for purple wire, but since this is only a single wire, I decided to use some of it up. I had a really hard time getting it attached to this terminal block here for some reason. Anyway, next task is these bolts here are just too large. They don't fit any of my cables. This is the 500 amp shunt, as you can see right there, 75 millivolt. I will go ahead and downgrade these nuts and bolts to M8 because I have plenty of those available. Even my double alt cables I don't think would fit on this. Alright, let's just take them out. So I've loosened them and you can see that this plastic piece comes off. I'll just take these nuts and bolts out. I'm going to reuse the hardware, the washers. At least I will try to. And just take these out. And as I take these out, the shunt will come loose from the platform that it's mounted on. Pretty interesting device. These are M8 bolts. Currently I don't have any longer ones, so I'll just have to use these. My favorite type of nuts to use are these serrated ones. I will use these for now. It will do the job until I get the correct hardware. Yeah, I think that'll do it. Okay, I had to drill out this bus bar that I'm using to mount the shunt because it doesn't fit the M8 bolt. I thought they would, but they didn't. Anyway, you can see I've enlarged the holes a little bit. There we go. Now I can get the M8 bolt through. I had to get me a battery so I can have some light and see what I'm doing. Alright, I got the shunt wired in right over here. I'm going to get my inverter back up and running, my lights back on these batteries here. I temporarily have them on these two batteries here just to keep the lights on. I had to disconnect everything. The shunt is temporarily mounted here. I'm going to test it for a while and make sure it suits my requirements before I get too excited about how exactly I mount it. It's coming off of the battery. This is the battery side. This is the charge controller, and this is the inverter. This cable goes to the other battery, so it's okay to have a cable behind the shunt. That's not a problem. I've got to move my LED lights over. This white connector here is actually where the battery meter plugs in, so I'm going to plug that in. Not much room here to work. Alright, it's plugged in. And there's the end results. I do need to plug my voltmeter back in. Let me do that now. I've got to move my LED lighting over back to the battery. I'm just going to temporarily clip it on here after the shunt. Make sure that's taken into account. And I'm going to move the positive over here. I'll just clip it on here for now. Really need to get my lights up. Okay, there we go. Alright, we're up and running. Already drawing 1.4 amps. It's not accurate to say there's 0 amp hours. That's just because I haven't set the meter up for this battery bank yet. Alright, let's go ahead and get the inverter back up and running. There we go. Looking good. Let's go ahead and fire up the charge controller. And let's turn the PV back on. Let's see, there it goes, 400 watts. Looking good. 31 amps going in. Excellent. Looking good so far. Well, that was a lot of work. The camera footage doesn't do it justice. It's quite tedious. But that should at least get me back up and running. I like the way this is turning out. It's starting to look pretty decent. It's a lot cleaner than what I normally would do because I have all the wire management. The system is powered by these 100 amp hour watt cycle batteries. These were provided by Watt Cycle. I don't get any commissions for sales, but these batteries are doing very well. There's 2 of them, and it's about 2 kilowatts of power. And with these 2 100 amp hour units, I can actually power my air conditioner, my computer, my lights, everything I need to do. I have 1200 watts of solar coming in through those breakers into that charge controller, and it's no problem. It runs like a top, performs very well. Really don't have any complaints. If you want to buy these batteries, there is a discount code in the description, but like I said, I don't get commissions. That's to prevent me from being biased. However, I will say that these batteries perform very well. They work as advertised. The rating is good. They have 100 amp hours in them. Some batteries you will find don't have their rated capacity. These absolutely have 100 amp hour in them plus a little extra. And that's good, that's the way it should be. Plenty of system upgrades and videos are on the way. I'm still working on completing this installation, and all future videos will be in a single playlist linked down below. Thanks for watching and hope to see you next time.